Hi Tree, thanks for tuning in for another episode of Math with Mullins. Today we're looking at our Unit 5 test review, all about triangles, so let's go and get started. The first one is we're trying to solve for x in questions 1 through 6. So I know that I can add all of my numbers together and be equal to 180. So 6x, and then 50 plus 80 is 130, but minus 4 is going to be 126, is equal to 180. And then I'm going to subtract 126 from both sides. I'm going to get 6x is equal to 54. And then divide both sides by 6. I'm going to get x equals 9. For number 2, again, the same thing. I have a 2x here, but then I have 90, 65, and 25. Adding those together, I'm going to end up getting 180. And that's equal to 180. So when you subtract 180 on both sides, you end up getting 0. So 2x is equal to 0, so that means x has to be equal to 0. Number 3, again, adding up all of our numbers, we're going to see 180. I started with this one a little bit differently. I subtracted 180 and 137, and I get 43. So all I did there is I took all of my numbers, so 180 minus 48 minus 89 minus 49, and I'm going to get negative 6. So D is negative 6. And then same thing here for number 4. I just started with 180, subtracted 50, then I subtracted 75, and then I subtracted 61, and I got negative 6 for this one as well. And then for number 5, this one, you can do a few different things. What I did first is I tried to figure out what two numbers could I add together to make 110, and that means this angle would have to be 50 degrees. So my two consecutive interior angles are equal to my third exterior non-adjacent angle. And then I said 50 plus 60 is 110, and then 110 minus 80 is going to give me 70. Didn't really need that for that portion, but now we can use this for x plus 137 plus 50 equals 180, or 187 plus x is equal to 180, so that means x is equal to negative 7. And then same concept here, I took 109 minus 180, and I got 71, and then 71 plus 77 is 148, minus 180, I'm going to get 32 for this corner. So 180 can be equal to 32 plus 23x plus 10, or 180 is equal to 42 plus 23x. I'm going to subtract 42 from both sides, so 180 minus 42 is going to be 138, is equaling to 23x, and then dividing both sides by 23, I'm going to end up with x equaling 6. Okay. Next up, for questions 7 through 12, determine if the two triangles are congruent, and if they are, state how you know. So this one we could say yes, due to the HL congruency theorem. We can say that our hypotenuses and legs match in our right triangles. For number 8, we said no, there is not enough information. We just have two sides, and I can't prove an angle or another additional side needed. For number 9, this one also can be a yes. I used HL for this one because, again, we have matching legs with a matching hypotenuse. And then number 10 is also a yes. We have these two angles, but we also have these two angles right here because of vertical. So if you go around your perimeter of your triangle, we have angle, angle, side. For 11, this is another yes, using the hypotenuse leg theorem. And then for number 12, we can say yes as well because we have side, angle, side. So yes, using SAS. That's going to be the end of your first half of review. So if you're just doing day 1, you can pause here for now and come back later. Otherwise, we'll keep going and check in the second portion of our review. For questions 13 through 16, state what additional information is required in order to know that the triangles are congruent for the given reason. So we want angle, angle, side. Really, we just need to know that 2 sides would be congruent. So we already have angle, angle. So we probably just want NL to be congruent too. And then we did 2 to 1. So I'm going to say H to J there, or J to H. Okay. For side, angle, side, we already have 2 sides, and we know that these angles are equivalent, so we just need this next side here. So we just need to know that ED is congruent to UD, or DU is equal to DE, either one. Side, 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 we need to figure out what this third side is. So is KL actually congruent to RJ? And then for angle, side, angle, just looks like we need angle B to be congruent to angle V for angle, side, angle. Okay. Now we're looking at questions 17 through 20, finding the value of x. This is an isosceles triangle, so x has to be equal to 10, where we have 2 matching sides. Number 18 is an equilateral triangle, so that means all sides are congruent. Seeing that all angles are congruent, we can say x is equal to 9. This next one, though, we had to use a little bit more information. It says the measure of angle 2 is equal to negative 24 plus 4x, and I know that this is an isosceles triangle, so I would just take 180 minus 100 and divide that by 2, or 80 divided by 2, that's going to give me 40 for each angle. So that means 40 is equal to negative 24 plus 4x. So I'm going to add 24 to both sides. I'm going to get 64 is equal to 4x. So that means x is equal to 16. Okay. And then same thing here for isosceles. I can start with 180. And actually, I don't even have to do 180 starting with 180 because my 2 bottom angles will match. So these are both 37. So minusing or subtracting 37 2 times from 180. I'm going to get 106 as the equivalent to angle 2. So 106 is equal to 5x plus 6. Subtracting 6, I'm going to get 100 is equal to 5x. So that means x has to be 20. Okay? And then our last ones, we're finding a few missing links and some proof. So in the diagram, DG is equal to FE, and angle FDG is equal to EFD. So we know that our triangles are congruent now. We can use side, angle, side for that. So what I did first is find x. I set 6x plus 4 is equal to 4x plus 8. Subtracting 4x from both sides. I'm going to get 2x. Subtracting 4 from both sides is equal to 4. So that means x has to be equal to 2. And then FG is going to be congruent to DE. So DE can be found by taking 4 times 2 plus 1. So DE is equal to 9. And then we have our proof. So I'm going to go ahead and type these out. So we're going to have our statements and our reasons. And let's go ahead and get going on that. Okay, so statement number 1 is going to be our given coordinates of triangle ABD and ACD. Okay, and then 2, I'm going to say that AB is equal to 4 and AC is equal to 4 using the distance formula. Then I can say that AB is equal to AC using substitution. Next, I can say AD is equal to AD using the reflexive property. reflexive property. Next, statement 5, BD is equal to the square root of 8, which is going to end up being about let me figure that one out real quick. Square root of 8 is about 2.83. And CD is also equal to the same thing, 2.83, and that was using the distance formula. So BD is equal to CD using substitution. So triangle ABD is equal to triangle ACD using sides. All those sides are going to match. Okay. And then our last one, we're trying to prove that QR is parallel to SP. So this one kind of has a little bit of extra going on here. I was thinking I could insert a table, but we'll do that. So we're going to have our statements, and then we'll have reasons. So statement 1 is going to be our QP is equal to RS, and QP is parallel to RS. And those are going to be our givens. Statement 2, I'm going to say angle QPS is equal to angle SRP using alternate interior angles. So I'm going to go back here and just show you how I'm getting that. So QPS, QPR, sorry. QPR is congruent to SRP using angle side angle. And then I'm just going to write this one. PR is congruent to PR using reflexive. And then angle, I got side, angle, side now. So I can say triangle RQP is congruent to triangle PSR using side, angle, side. And then, because of that, angle QRP is congruent to angle RPS using the congruent parts of corresponding triangles are congruent, so our CP/CTC. So QR can now be parallel to SP using my alternate interior angles converse. Okay, so, and I might have given some extra steps there too, but that was kind of how we filled in with CP/CTC. That'll be it for our review. Thanks so much for tuning in. Hopefully this gives you some guidance on studying for your Unit 5 test, and we will catch you next time. Have a great day. Bye.